Hello once again, ladies and gentlemen, and welcome to our virtual classroom. Today we are going to be going over quadrilaterals. As always, I do recommend that you pause the video as you go along so you can take the notes and then follow along. Pause and resume as you see fit. So before we begin, we are doing numbers 5, and then we're skipping 6 and 7. We're going to 8. And then we're doing 8, 9, 10, 11, 12, 13, and 14. All right, quadrilaterals. The word quadrilateral can be split into two words, the word quad and the word lateral. Of course, the word quad means 4. If you've ever ridden a quad bike or a quad, I don't know if you've ever done a quad stretch, if you are in a sport. Those are 4 major muscles. That's why we call them the quadriceps, the quad stretch. So quad means 4, and lateral means side. So quadrilateral means a 4-sided figure. Easy enough, right? Quadrilateral. Another word that you need to be familiar with, though, as we're talking about quadrilaterals, is the word polygon. Now, the word poly means many, and so or more than one, really. And so a polygon is a closed figure, so made up of straight lines, with 3 or more sides. So anything from a triangle, that is the polygon with the least number of sides, to a quadrilateral, 4-sided, like a square, rectangle, and then pentagon, and then hexagon, etc. But yes, beginning with a triangle, moving on, those are polygons. I'm sorry about that. And the polygon that we're talking about today is the quadrilateral. The quadrilateral is a polygon with 4 sides. So that's pretty simple. So a quadrilateral, really any shape that has 4 sides. It may even look kind of wacky and weird, but any shape that has 4 sides is considered a quadrilateral. Obviously, we have squares and rectangles, but really any shape that has 4 sides is considered a quadrilateral. But there are some special quadrilaterals, and we give them special names, beginning with this first one right here known as the trapezoid, a trapezoid. And yes, this right here is an example of a trapezoid. And a trapezoid is simply a quadrilateral with 2 parallel sides. 2 of the sides are parallel. So here, looking at this trapezoid, we see that this side and this side are parallel, and I note that by putting some arrows right here to know that there are parallel. What does it mean for something to be parallel? Well, think about 2 straight lines that will never touch, like 2 train tracks that go straight and they never curve and they never touch one another. That is what parallel means. It's 2 lines that if you were to stretch them out forever, they would never touch. So notice how here, these 2 lines, if I could stretch them out forever, these lines would never, ever touch, no matter which direction I stretch them into. They would never, ever touch. So that's what makes these. So those are the 2 lines. This line and this line on this trapezoid would never touch. But when I look at the other 2 lines, notice that if I were to stretch those out forever, not even that far, I see that they would eventually touch. So those are not parallel. Only these ones in blue are parallel. It has 1 set of parallel lines, only 2 parallel lines, 2 parallel sides. So that would be a trapezoid. Now, trapezoids can look very different from one another, but as long as you see that it's 2 lines that are parallel, then that makes a trapezoid. So this would be another example of a trapezoid. This would be an example of a trapezoid. Because again, we have 2 lines, these 2 right here, that are parallel, and the other 2 are not. All right, so that is a trapezoid. All right, so that's the first quadrilateral. We have 2 sides that are parallel, the other 2 are not. Moving on, our next special quadrilateral is the parallelogram. The parallelogram. All right, and notice how the word parallel is there in parallelogram. That is because a parallelogram is, again, a 4-sided figure, and a better definition than this one is where opposite sides are parallel. So you have 2 sets of parallel sides. All right, so opposite sides are parallel. Opposite sides are parallel. All right, so we have 2 sets of opposite sides. So for example, if I were to draw something like this. So here, straight line, here we have another straight line. These two are parallel, and then we have another line here, another line here, and these two are parallel. So notice how the top two lines are parallel, this one and this one. So that's one set, those are two lines, and the other two lines are parallel, they will never touch. That is the most general definition of a parallelogram. All right, opposite sides are parallel. All right, that is a parallelogram. And there's other things that are true, but that is basically what a parallelogram is. Now, notice how, because those are parallel all the way around, you can also kind of see that opposite sides are also the same length. Opposite sides are also the same length. Interesting. We'll talk about the angles in a little bit, but I don't want to overwhelm you. But yes, a parallelogram, opposite sides are parallel. All four sides, you can say, have a parallel opposite line. All right. So that is a parallelogram. That is the general definition. Every single parallelogram in the world will follow those rules. However, there are some special parallelograms that go beyond this. Special parallelograms that go beyond this. And so aside from just parallelograms like the one that I drew, we have three special parallelograms, which you guys are probably familiar with. We have the rectangle, which is, there's an example of it right here. We have the rhombus, which we have an example right here, and we have the humble square, which is right here. So a rectangle is a parallelogram, and here's a picture of one. Notice how opposite sides are parallel. Opposite sides are parallel. So this sides are parallel and this sides are parallel. Opposite sides are equal. Awesome. But this is what makes a rectangle special. A rectangle has four right angles. Four angles that each measure 90 degrees. That's what makes a rectangle so special, that its angles are all 90 degrees. They're all right angles, each one of these. And I'm not talking about the length. Remember, length is from here, from here to here. So for example, let's say that this was 10 inches. That would be the length, but the angle, how open it is, it makes that corner looking thin. That's what the angle is. Measuring from here to here with a protractor, you would measure 90 degrees. All right, 90 degrees from there to there. That has nothing to do with the length of the sides. All right, obviously opposite sides are the same. So this is 10, this is 10, and this is 7. This will be 7 as well. But again, what makes a rectangle special is that it has four right angles. Notice how rectangle rhymes with right angle. Rectangle, right angle. So rectangle is a parallelogram with four right angles. Awesome. The next one is the rhombus. The rhombus, which is a parallelogram. Everything about a parallelogram applies. Opposite sides are parallel. Something about parallelograms that is also true is that opposite angles will be parallel. So this angle right here and this angle right here are going to be exactly the same. So if this was 115 degrees, this would be 115 degrees. And the other one as well, if this was 65 degrees, this angle, then this one's going to be 65 degrees also. So opposite angles are equal. Opposite sides are equal. Opposite sides are parallel. But this is what makes a rhombus so special, that it has four equal sides. Four equal sides. So this side and this side are the same, but this side and this side are also equivalent to that. So it's almost like a square, and yet it's not a square because the angles are slanted, right? Or the lines are slanted. So, but yes, four equal sides. So I know that if this was 4 inches, then this would be 4 inches, and this would be 4 inches, and this would be 4 inches. So that's what makes a rhombus so special. Rectangle has four right angles. Rhombus has four equal sides, and a square, we put them both together. A square is a parallelogram with four right angles and four equal sides, all of which are parallel to each other. Okay. So a square is like putting a rhombus and a rectangle together. So again, a parallelogram, no matter what the parallelogram looks like, it is always going to fulfill these two things right here. Three things really. Opposite sides are congruent, and congruent just means the same. Congruent just means the same or equal. So the opposite sides on a parallelogram will always be the same length. So if this is 5, this is going to be 5. If this is 3, this is going to be 3. If this is 7, and this is going to be 7, because those are opposite sides, right? If this is 8, this is going to be 8, etc. Of all parallelograms, opposite angles are going to be congruent. So obviously in a rectangle, they're all 90. In a square, they're all 90. But if it's just a parallelogram or rhombus, if you know what one side is, you can figure out the other angle because they're going to be the same, right? And so opposite sides are congruent, opposite angles are congruent, and opposite sides are all parallel because it's a parallelogram. But a rectangle has 4 right angles, a rhombus has 4 equal sides, and a square will have 4 right angles and 4 equal sides. Awesome. The last thing that I want you to see about parallelograms is consecutive angles. Again, I encourage you to pause this as you go. However, I would include that this applies only to parallelograms. This is for parallelograms. There you go. Consecutive angles. And consecutive angles, guys, are simply angles on the same side. They are simply angles that are on the same side. All right. So, for example, if I split this in half, these 2 angles are on the same side. All right. If I split it in half the other way, then these 2 angles are on the same side. And all I want you to know about consecutive angles, and we'll talk more about this tomorrow, is that consecutive angles will add up to 180 degrees. Consecutive angles, angles on the same side will add up to 180. So if I cut this in half, these are on the same side, 115 plus 65 will be 180. That is important because a lot of times they won't give you one of the angles, but I know that because they're on the same side on a parallelogram, that 115 plus that missing angle together should give me 180. So I can easily figure out just by solving this equation that my missing angle is 65 degrees. All right. So ladies and gentlemen, I'm going to make a second video where I actually go through the examples, but for now, those are the notes, and hopefully you find that helpful. Keep an eye out for another video on this same folder that is going to go over the actual examples. So until then, I'll see you next time.